In this example, I want to make a workflow comparison to show what the procedure would be like using SolidWorks only to create presentation graphics for technical illustrations. By comparison, I have a PDF document of a similar document that I created using 3D via Composer to generate my technical illustrations. There are three images I'm going to need to create. The first is a cover image. The second is an image that shows the explode sequence and the removal process of the spray tip, and finally a warning image that highlights with a detail breakout the electric motor. Using SolidWorks alone, we can actually do a pretty good job of creating some presentation graphics. There are some tools that we have that allow us to do things like saving named views or custom views. So I can remember a particular view orientation if I need to return to that quickly. So for my cover image, I want to try to make as realistic of an image as possible without using PhotoView 360 for a rendering tool. Let's enable Real View, shadows, and even perspective. And let's change the rendering style to include the hidden lines. And that's a pretty decent looking image. I think that's about as good as I'm going to get without using PhotoView 360. So let's capture a screen capture of that still image. And then using a graphics editing program, and here I'm just using Corel Paint Shop Pro, we'll paste that in as a new image. I can use Paint Shop Pro or Adobe Illustrator, whatever my graphics program of choice is, to make additional graphics edits, but that's not really the point of this demonstration. So at this point, we'll just go ahead and save this as a JPEG. And next we can go back to SolidWorks and we can work on the next step. I've saved a named view for the next view orientation as well. And here we're just kind of zooming in on the spray tip area. I might want to remove some of the unnecessary components so I can hide out any components I don't want. And a good way to do that and automate that is to use display states. Display states will remember the hide show status of various components so I can quickly revisit them. Okay, so I've hidden out some of the unnecessary components. What we need to do next is to create an exploded view. And I'll go ahead and explode the spray tip and the nozzle, and we'll just pull them out with the on-screen handles. Like so. That looks good. And then for another step, we're going to grab the three components of the swirl valve assembly and drag those out. Now SolidWorks does have a very intelligent autospace command, so when I grab the components of a subassembly, it automatically spaces them, and that's pretty handy. And so that's looking good. Now what I am limited to here in SolidWorks though is I don't have the special effect graphics to create like dynamic arrows and things like that I can do in 3D via Composer that really add that extra degree of intelligence to my technical illustrations. So really this is about the best I can do with this view. We might want to change the rendering style to a hidden line removed. And now we're ready to screen capture this image. With that image in hand, we'll go back to Paint Shop Pro, paste in the new image, and of course here in my graphics editing program, I'm at the mercy of whatever tools it has, such as arrows, and I can certainly add an arrow and maybe try to rotate that into position, but I don't have the intelligence of attaching to geometry, and it's certainly not associative to my model as well. So if I make any changes and re-output the image, I'm going to have to make these special effect graphics all over again, whereas in 3D via Composer those things update automatically. So a little bit of a limitation of my graphics program here. But now we'll go in and save this image as a JPEG. And this is going to be my remove tip image. And finally, back to SolidWorks, we'll create our third image. We'll collapse the exploded view and take a look at another named view where I've oriented the model in the desired location. And I've also saved a display state that shows the model with one of the covers hidden and one set to transparent. And this is going to give us that nice detail breakout showing the electric motor. We don't have a way to superimpose two views on top of each other in SolidWorks, so this next graphic, in order to create the image that you see here in the PDF document, we're actually going to have to do this in 2 steps in SolidWorks. First, we'll create a static image of the breakout, and we go back to Paint Shop Pro and we paste that as an image. Now back in SolidWorks, we can show the default display state, which shows all the components. Put that into a hidden line removed, and now we save a screen capture of that image. In Paint Shop Pro, we paste as a new image. Now we need to prepare the detail breakout using some of the tools in my graphics editing program. I can crop this and get the border looking the way I want. Now in the interest of time, I've gone ahead and done that already. And this is what I've come up with. So the next step is to copy and paste this image into our main image. Something about like that. Now I would just use my graphics tools, arrows and other manipulators to try to get this looking as professional as I can. Something like this maybe. And then the point of this image is to warn the user not to expose the motor to any liquids. I've already got an image on file for the universal keep dry symbol. Let's go in and open that image up, copy it, and paste back into this image. Right about like so. Okay, this is about as good as we can get with the graphics tools built into Paint Shop Pro, so I'll go ahead and save this one out. And now I have my 3 images, my cover image, my remove tip image, and my warning image. We can now go to the Microsoft Word document and just link to these images. First is our cover image. Next, our warning image, and finally the tip removal image. Update the links, and now we have a document set that was prepared in SolidWorks. So let's side by side these. First off, you notice that there's a little less intelligence in the static JPEG images as far as the maintaining the aspect ratio. So this image looks a little bit compressed. And then second of all, even though the output quality of SolidWorks is great, what we really lack is the professional looking special effects graphics. Not only does it give a more professional appearance, but there's an associativity to it to where any changes to the model will automatically have the graphics update, whereas using SolidWorks to generate our image, we're then relying on our third-party graphics program to create these special effects, which means that any time a model change takes place, we would have to output brand new images, bring them into the graphics program, and edit them every single time. And that's where the real time and cost savings is into to working with 3D via Composer, let alone the ability to create much higher quality technical illustrations. So as a final exercise in our comparison of the workflow between SolidWorks and 3D via Composer, let's now imagine a scenario where a design change is brought about. We're now looking at the Word document that was created using the graphics from 3D via Composer. Let's go back to SolidWorks and imagine that a design change has come about such that we've changed the spray tip, changed the container, and due to corporate branding, the color scheme has changed. Remember that in SolidWorks we would need to visit each of the saved views, re-export all of the JPEG images, open them up in our secondary graphics editing program to apply the special effects graphics, and then reinsert those back into our Word document. However, in 3D via Composer, we simply need to update the Composer document, which is a direct link back to the SolidWorks file. You'll see that immediately all of our image graphics update, including the special effects graphics, so no secondary editing is required. In fact, let's go ahead and also change the rendering style for each of these images just for effect. I'll use the flat technical rendering style. Incidentally, this is a rendering style that would be difficult, if not impossible, to create in SolidWorks. Once I have all my images formatted the way I like, I simply re-export all of my high-res images in batch mode. Return to the Word document and update the links. Just like that, our technical documentation is up to date. Again, trying to reproduce those steps in SolidWorks would be pretty time consuming, not to mention the fact that the output quality just doesn't match what we can generate in 3D via Composer. So to summarize, why 3D via Composer is advantageous to just using SolidWorks: number one, multiple rendering styles. The fact is that even though SolidWorks can create some great output, there are just certain rendering styles that lend themselves to technical illustrations that we just can't create in SolidWorks. Second, the special effects graphics of 3D via Composer allow us to create a very polished and professional looking graphic that we can't create in SolidWorks without doing some secondary editing. Finally, and probably the most compelling reason that 3D via Composer is superior for technical communications, is the associativity to the solid model. Anytime the SolidWorks model changes, those changes easily propagate to all of our technical illustrations when using 3D via Composer.